everyone. So in this video we are going to discuss another interesting multi-letter cipher that is known as Hill cipher. So first we will discuss about the encryption of Hill cipher. In this video I am going to discuss about how to encrypt using Hill cipher. So we are going to discuss about encryption of Hill cipher, and next video will be about the decryption of Hill cipher. So when we talk about Hill cipher, so the encryption algorithm is, let's say C is the ciphertext, so algorithm will be CEKP. So encryption of P is the plain text and K is the key. So it is always going to be P into K mod 26. When we talk about, let's say this is equation number 1, and when we talk about the decryption or how to get plain text, so decryption will be on ciphertext, key and ciphertext. So DKC is going to be C into K inverse mod 26. And what is C here? C is P into K. So it will be P into K inverse mod 26, which is ultimately going to be P. So this is how we do decryption. So in decryption I'll be talking about decryption in the next video. Let's talk about the encryption process. So encryption is here, everything we are going to take in the form of matrix. Plain text also will take in the form of matrix, and key also will be in the form of matrix, and then it is going to produce ciphertext in the form of matrix. So if you look at this cipher, whatever ciphers we have discussed, starting from the Caesar or shift cipher, then we came to monoalphabetic cipher, Playfair cipher, Vigenère cipher. So this is a bit like calculation of this Hill cipher, a bit complicated. So pay attention to when we do it. So let's say this C1, C2, C3 are ciphertext letters. So this ciphertext letters can be formed as P1, P2, P3, which are plain text letter, and it is key K11, K12, K13, K21, K22, K23, K31, K32 and K33. So this is matrix multiplication. How we are going to get the ciphertext? We are going to get ciphertext using matrix multiplication. First thing. Second thing is, this key size, it is not fixed. It can be, this key can be of any size, okay, but this key should always be a square matrix. So for example, here we have a key of size 3 into 3. We can have a key any size, it should be, but it should be n into n. It should all 3 into 3. It can be any size matrix, but it should always be a square matrix. So like for example, this key is a square matrix of size 3 into 3. That's why we take 3 letters of plain text. If key is 2 into 2, then we take 2 letters of plain text. If key is 5 into 5, then we will use 5 letters of plain text. So this is one thing to be noticed. So when we talk about like matrix multiplication, so how we do? C1 will be this should be multiplied with this row, should be multiplied with this column and taking sum. So it will be like P1 K11 plus P2 K21 plus P3 K31. And just remember that all these operations are mod 26. So we can write here mod 26. Similarly, we can write C2 is equal to P1 K12 plus P2 K22 plus P3 K, sorry, here it will be K31 plus P3 K32, and it will also be of mod 26. In the same manner, we can write C3 also. So C3 is going to be P1 K13 plus P2 K23 plus P3 K33, and it is also mod 26. So this is how we can get ciphertext using plain text and key. So let's first use a small example and then we will go for the larger one. So this is just a kind of revision. The ciphertext we can get using the matrix multiplication. Here we write plain text and key in the form of matrix. So key matrix should always be a square matrix. There is no limitation of size, but it should be a square matrix. It can be 2 by 2 matrix, it can be 3 by 3 matrix, it can be n by n matrix. So this is how we multiply matrix and we can get each letter of ciphertext. This plain text letter character, number of plain text letters and number of ciphertext letters depends upon the size of key. If it is 3 into 3, I have taken example for 3 letters or 3 alphabets. If it is 2 into 2, we will take 2 alphabets. So let do one simple example using 2 alphabets, using 2 into 2 key. So let's say our plain text is let C. The plain text is let C, and we are going to encrypt this plain text using the key which is a 2 into 2 matrix 5, 8, 9 and 3. We are encrypt this using a 2 into 2 matrix which is 5, 8, 9 and 3, and this is our key. And the process, the cipher which we are going to use for this is Hill cipher. So using this Hill cipher, we are going to encrypt let C with the given key. Okay, so I am not going to write again here the value of A, B, C, what is 0, what is 1, what is 2, what is 3. So by the time you all people know that what is A, B, C, D. So starting from 0, A will be 0, B will be 1, C will be 3. Likewise, we will use. So because this key is a 2 into 2 square matrix, what we'll do? We will encrypt 2 letters at a time. So now we will divide our ciphertext into a group of 2 letters like this. Okay, now let's say what represents the letter L. The number 11 represents letter L. Similarly, number 4 represents letter E. Similarly, number 19 represents letter T. Number 18 represents letter C, and E is represented with 4 and 4. So now first we will encrypt this LE 11 and 4. So the ciphertext for like C1, C2 for L and E is going to be 11, 4 multiplied with 5, 8, 9 and 3. So it will go into this way and it is going to be a mod 26 operation. So let me write it here. 11 into 5 which is 55 plus 9 into 4 which is 36. Similarly here 11 into 8 which is 88 and 4 into 3 which is 12, and it is going to be mod 26. So first is 91 and second one is 100. And when we do it with mod 26 operation, so it means when we divide 91 with 26, the remainder is 13. Similarly, when we divide 100 with 26, the remainder will be 22. And this 13 is for letter N, and this 22 is for letter W. So this LE is encrypted with N and W. This is our ciphertext and this is our plain text. Now let's do it with another next letters, that is T and S. So T and S are 19 and 18, and key is the same 5, 8, 9 and 3, and this operation is mod 26 operation. So let me multiply it and write it. So when we multiply 19 with 5, it comes out to be 95, and 19 with 9, it comes out to be 162. Similarly, 19 into 8, which comes out to be 162, and 19 into 3, which comes out to be 57. sorry, 18 into 3, which comes out to be 54, and it is mod 26 operation. So 19 into 5 plus 18 into 9, 19 into 8 plus 18 into 3. So 95 plus 162, which comes out to be 257, and 162 plus 54, which comes out to be 216, and it is mod 26 operation. So when we divide it with 257, the remainder is 23, and when we divide 216 with 257, the remainder is 8. So this is X, and 8 is for I. So T and S is encrypted as X and I. Similarly, we can encrypt the third one, which is E, 4 and 4. Key will be same. This is for T and S, and this is going to be for E and E. So key will be same, 5, 8, 9 and 3, and it is mod 26 operation. So 4 into 5, which is 20, 4 into 9, which is 36. Similarly, 4 into 8, which is 32, and 4 into 3, which is 12. So when we add it, it comes out to be 56 and 44. And when we take mod 26 operation, because it is mod 26 operation, so remainder will be 4, and here remainder will be 18. So this 4 is for E, and this 18 is for S. So the E and S. So let C is encrypted as NWXIES. This is ciphertext. So this is how we encrypt using Hill cipher. Now we will discuss a bit more long example, so that the things will be more clear to you. So this is our example number 1. Now we are going to discuss a bit lengthy example with the key size 3 into 3. So let's say in this second example, let's say the plain text P is pay more money. So the plain text is pay more money. Let me divide this page into two parts. Okay, so the plain text is pay more money, and the key is a 3 into 3 matrix. So key is 17, 17, 5, 21, 18, 21, 2, 2, 19. This is key. So this is a bit more complicated. So because this is a 3 into 3 matrix, what we do, we will divide plain text in a group of 3 characters. Like for example, pay, MOR, more, EMO, and NE, NEY. So let's write the letters for this numbers. P is 15 is for P, 0 is for A, and 24 is for Y. Similarly, 12 is for M, 14 is for O, and 17 is for R. 4 is for E, 12 is for M, and O is for 14. N is for 30, 13 is for N, 4 is for E, and 24 is for Y. So this is how we write. Now we will encrypt all these 4 blocks one by one. So first we are going to do it for pay. So let's do it for pay. How we are going to encrypt pay. So pay is 15024. 15024. And the key is 17, 21, 2, 17, 18, 2, 5, 21, 19. So what we are going to do? We are going to make a matrix multiplication. So 15 into 17 plus 0 into 21, which is going to be 0. So I'm not going to write it just to save my space. And 24 into 2, which is 48. Then 15 into 17. Then 0 into 18, This 0 into 18, I am not going to write it just to save space, and 24 into 2, which is 48. The last one is 15 into 5 and 0 into 21, which obvious reasons I am not going to write. Then 24 into 19, and this is mod 26 operation. This is mod 26 operation. Now 15 into 17 is equal to 255. 255 plus 48, 255 plus 48, and this is 75 plus 456, and this is mod 26. So 255 plus 48 is 303. So both of these are going to be 303, and this is 531, and it is mod 26. So when we divide 303 with 26, the remainder is 17. When we divide 531 with 303, 531 with 26, the remainder will be 11. So this 17 is for R. So for both 17 we are going to write R, and 11 is for L. So PAY can be encrypted as R, R, L. So the cipher text for PAY is RRL. Now we are going to take the second one. So second one is MOR. MOR. What we write for MOR? So the matrix, plain text matrix for MOR is 12, 4, 12, 14, 17. Then the same key we are going to write, which is 17, 21, 2, 17, 18, 2, 5, 21 and 19, and it is going to be a mod 26 operation. So let me write it. 12 into 17 plus 14 into 21 plus 17 into 2. Similarly, 12 into 17 plus 14 into 18 plus 17 into 2. So then this is 17 into 2. And the third one is 12 into 5 plus 14 into 21 plus 17 into 19, and it is mod 26 operation. So 12 into 17 is 204, 14 into 21 is 294, and 17 into 2 is 34. So 12 into 17 is 204 again. 14 into 18 is going to be 252, and 17 into 2 is 34 again. Now 12 into 5 is 60 plus 14 into 21, which comes out to be 294, and last one is 17 into 19, which is 323, and it is mod 26 operation. So when we add all these things, this is going to be 532, this is going to be 490, and this is going to be 677, and it is a mod 26 operation. So when we divide 532 with 26, the remainder is 12. Similarly, when we divide 490 with 26, the remainder is 22. When we divide 677 with 26, the remainder is going to be 1. So this is M, this is W, and this is B. So the cipher text for MOR is M, W, and B. Let's do it for these two also, EMO and NEY. So I'm going to use the next page. Again, let me divide it into two parts. So this is EMO, and the plain text matrix for EMO is 4, 12, 14. And the key is same, 17, 21, 2, 17, 18, 2, 5, 21 and 19, and this is again a mod 26 operation. So let's multiply these two matrix. So it is going to be 4 into 17 plus 12 into 21 and 14 into 2, which is 28. Similarly, 4 into 17 plus 12 into 18 and 14 into 2, which is 28. The third one is 4 into 50, which is 20, 12 plus 12 into 21 plus 14 into 19, and it is mod 26 operation. So 4 into 17 is 68 plus 12 into 21, which comes out to be 252 plus 28. Then 4 into 17 is 68, 12 into 18 is 216 plus 28, and the last one is 20 plus 12 into 21 is 252 plus 14 into 19 is 266, and it is mod 26. So if we add these three, so it comes out to be 348, this comes out to be 312, and this comes out to be 538, and it is mod 26. So when we divide 346 with 26, the remainder is 10. When we divide 312 with 6, the remainder will be 26, the remainder will be 0. When we divide 538 with 26, the remainder will be 18. So 10 is for K, 0 is for A, and 18 is for S. So it is EMO can be encrypted as KAS. And the last one is NEY. So NEY is the last one, and the plain text matrix for NEY is 13, 4, 24, and the key is same 17, 21, 2, 17, 18, 2, 5, 21, 19, and it is mod 26 operation. So let me multiply it again. So it will be 13 into 17 plus 4 into 21, which comes out to be 84, plus 24 into 2, which comes out to be 48. Similarly, 13 into 17 plus 4 into 18, which comes out to be 72, plus 24 into 2, which comes out to be 48. Similarly, 13 into 5, which is 65, plus 4 into 21, which is 84, plus 24 into 19. So let me do it. 13 into 17 is 221 plus 84 plus 48. Then 13 into 17 is 221 plus 72 plus 48. Then 65 plus 84, and 24 into 19 is 456. And again it is a mod 26 operation. So when we add these three, it comes out to be 353, this comes out to be 341, and this comes out to be 605, and it is mod 26. So it will be like when we divide it with 27, this remainder will be 15. When we divide 341, the remainder will be 3. When we divide 605 with 26, the remainder will be 7. So this is P, D, and H. So NEY can be encrypted as PDH. So as a whole, if you check the cipher text for pay more money, this was our plain text initially. So now for this, the cipher text is RRL M W B K A S P D and H. So this is our plain text, and the next one is going to be the cipher text. So you can check in the single line the character E. We have two E, which is encrypted as two different letters. So this is our plain text, this is our cipher text. This is how the Hill cipher works. So it's a bit complicated. So here I write this encryption algorithm in the form of PK. In some books you will find it KP. Like for example, this is row column, you can use column row also. So you can use column vector also. We use row vector, you can use column vector also. Like for example, when we write kp, so k will be here and then p1, p2, p3. It will be like this. This is our key k. So both are correct. This Hill cipher can be encrypted in both ways. So if you see, the encryption is a bit difficult, so to decrypt this, again we need to use the matrix multiplication and such type of method. So if you see here, I use k inverse. So k inverse, what is k? K is the matrix. So for finding k inverse, we need to find inverse of a matrix. So that is a different way. So I will be explaining how you can decrypt using Hill cipher in a next video. Thank you.